Hello. This is a lecture on the material in section 7.2 for Math 201 and Business 230. It's really a hypothesis testing, all right? So before our last test, well, it was before spring break even, really, we went through and we looked at all the different pieces of this process. And now we're going to put them together. Two things that's going to be common to the ones we're going to do in this section is they're going to use the p-value method instead of the rejection region method. All right, and the tests are going to be hypotheses or claims about the mean when we know the standard deviation of the population. All right, so I've got this little blurb up here. Let's see how long this video takes. I want it to be under 15 minutes if we have time after I've done the other stuff that we need to do. I'm going to come back and talk about this. It's an application of statistics, really, of confidence intervals to some of the things that are going on with the virus, right? All right. So what I have here on the left side of the screen, starting here is the hypothesis testing process. You have this listed. I think the document's called hypothesis testing outline, maybe. I'm not sure if it's outline or process in the course content area, in our course content area in Blackboard. If you don't have it, it might be worth it to pause the video and go get it. It's not necessary. I've got it here. One thing I'm going to suggest to you when you first start doing these is if you grab the outline and have it written on next to you when you work your way through these questions, it'll make it easier to know what to do next. Now, you have to remember that there's some questions in the homework that will ask you for individual pieces of this thing, okay? So you have to be able to do the individual pieces, but the outline helps you put them together in the right order. All right, in auto racing, a pit stop is where a racing vehicle stops for new tires, fuel repairs, and other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of a race. A pit crew claims that its mean pit stop time is less than 13 seconds. All right, so there's the first, so less than 13 seconds. A random sample of 32 pit stop times has a sample mean of 12.9. It says assume the population standard deviation is 0.19 and alpha equals 0.01. All right, and like I said, these are going to be p-values. So step one in the process, verify it's random. Well, we're going to assume that, and that the population is normally distributed or n's bigger than 30. Well, n was 32, so we're good with that. Now let's write down the key things here. So n is 32, right? Our sample mean, x bar, was 12.9. Our claim was less than 13, so we're going to get to that in a minute. But the claim is what is mu in the formula, all right? So mu will be 13 because that's the claim. And then the population standard deviation is 0.19, and alpha is 0.01. All right, step two. Write the null and alternative hypotheses. Null alternative. All right, the claim this time is less than, right? There's no equality in it. So that means it's right here, less than 13. So the complement of less than is greater than or equal to. And the claim was the less than, so let's remember to mark that right here because we'll need to remember later which one was the claim. All right, step three is just about what kind of tail it is because we're going to need that in a later step. Remember, the tail matches the alternative, right? So the tail matches this. It's less than, point to the left if you will. This is a left-tailed test. All right, step four, find the standardized test statistic. Whenever we're dealing with a mean, the standardized test statistic is the mean of the sample minus the mean from the claim divided by the standard deviation, which remember is the standard deviation, the original one divided by the square root of n. All right. So in this case, what we get for that is 12.9 minus 13 over 0.19 divided by the square root of 32. Okay, so now at this point, part of what's happening here is that, I mean, I've pre-calculated these to condense the time on the video. So you may want to pause this and do your own calculation, but I've got it already at minus 2.98. All right, step 5. Now remember, this says we're doing the p-value method, and we need to know what kind of tail it is. It was left-tailed. So the p-value left-tailed, here's the formula. Normal, so our p here is normal CDF. This is the calculator command. Minus our 4 nines. Then we have this here. This is, I abbreviate this. This is our test statistic. So you can see in the formula over there, I abbreviated TS. It's minus 2.98, comma 0, comma 1. All right. And that equals 0.0014. All right. Step 6. We're going to reject or fail to reject the claim. So what we're going to do is we're going to reject it. If, so let's remember here, alpha was 0.01, right? Okay. And here's our p-value, right? This was our p here, right? So in this case, we've got 0.001 is definitely less than 0.01, right? So I've got the p-value is less than alpha. I reject the null hypothesis. Okay. It's actually, if it's less than or equal to, I reject. In this case, it's less than. Now, last step then, make a decision about the claim. Now, if you remember here, let's go back up. The claim matched the alternative. I just rejected the null, so that I'm more or less accepting the claim, right? But that's not the formal language. What I'm going to say here is there is enough evidence to support the claim. All right, so that's our first one. Let's do another example here. Okay, so you see what we've done. We did on the first one, we're going to do the same thing here. We're using our hypothesis testing process, which we've practiced before. And we've got examples here. All the questions in this section of the book are going to be p-value questions. And they're going to have, well, we're going to know the standard deviation of the population, which means we're going to use the standard normal instead of the t-test, okay? All right, so let's move on. Let's do the next one. According to a study of U.S. homes that use heating equipment, the mean indoor temperature at night is 68.3 degrees Fahrenheit. You don't think this is right. So you randomly select 25 U.S. homes that use heating equipment in the winter, find that the mean indoor temperature at night is 67.2. From past studies, the population standard deviation, right? See, they give us the population one, is 3.5 Fahrenheit, 3.5 degrees Fahrenheit. And here this time they're telling us it's normally distributed. They have to tell us it's normally because the sample size is less than 30, right? All right, is there enough evidence to support your claim at the alpha equals 0.05? Okay. All right. So what's happening here is the wording on this one's a little bit odd. What we would normally do is we're going to say the claim is the study, right? So the claim is that they're equal, and we're going to test whether or not they're equal. All right, so step 1, verify the sample is random. We assume that. They told us it was normally distributed, okay? And in here, so let's just go ahead and write down our other information here. The claim, if you will, the mean from the claim is 68.3. The sample size is 25. The mean from the sample is 67.2. The population, standard deviation, is 3.5. And we're going to use an alpha, that is a level of significance of 0.05. All right, step 2, write the null and alternative hypotheses. Well, this time, this claim is that the temperature at night is, right? Is equals. So the claim is that the mean equals 68.3. Well, it's definitely got equality in it, right? So that's the null. There's the claim. It's the claim. So the complement of equal to is not equal to. All right. Step 3, you can look over here. Step 3, we got to determine the tail. Again, remember the tail comes from the alternative. The alternative is not equal to. That means this is two-tailed. Not equal to is two-tailed because we're going to reject the claim if the data is either too low or too high. So it's two separate ways to reject. That's two-tailed. Step 4, find the standardized test statistic. Mean of the sample minus the mean from the claim in parentheses. Standard deviation divided by the square root of n, which is the standard deviation for the situation with a sample, right? So 67.2 minus 68.3 over, what was it, 3.5 divided by the square root of 25. Now, I'll make a little comment here. People often get the order on this wrong. They forget which one is X bar and which one is the claim, right? It's always the number from the data minus the number from the claim. All right, always. In testing hypothesis, that's always what we're going to do. All right. So let's move a little further. Oh, wait, this one turns out to be minus 1.57. All right. Now we have to find the p-value. So the p-value formula for two-tailed, you have to look, there's two options. If the test statistic is less than 0, you do this because you're going to do a minus 5 nines. Okay. If it's greater than 0, you're going to do a greater than. Now this one was negative, right? It's less than 0. So we're going to do normal CDF. Well, I'm sorry, wait a minute. It's two-tailed, so I'm going to do 2 times normal CDF. Minus 4 nines, or 5, whatever you want there, minus 1.57, 0, 1, right? This ends up being 0.1164. Okay, so this is our p value. Now we've got to make our decision about the null hypothesis. That's step 6. Remember, our alpha this time was 0.05. Which is less than our p-value of 0.1164, right? When alpha is less, right? When that alpha is less than the p, or the p is greater than the alpha, however you want to say that, then we fail to reject. No, right? The official rule over here is, I should have written in the p's here. So when p is less than or equal to the alpha, we reject. When p is greater than alpha, we fail to reject. All right, last step then. Now we need to make a decision about the claim. And the claim, if you remember, matched the null this time, okay? So we just failed to reject the claim, and the claim matched the null. All right, so we just failed to reject the null. The claim matched the null, so we failed to reject the claim. All right, so what that means, we failed to reject it, so that means there's not enough evidence to reject the claim. Now let me go back in here real quick. You see where I have this normal CDF thing over here? Now I haven't written out both the calculator way this time because I wrote it over here. Okay, so you'll see, like right in this column here, right? There's the calculator method. Here's Excel. Okay, so the Excel method is here. You can use that. You get the same numbers, right? Same thing applies up here, right? The Excel method's over here.